Hello and welcome to Scalable CTO. I'm Bob Dickinson. Today we're going to talk about something I built. I'm in the process of building TeamSpark.ai. So let's get into it. We'll talk a little bit about what it is. This isn't going to be like a full-on explanation of the product and market and the whys. It's going to be more of a technical exploration of what we've actually built. We'll have a demo, talk about architecture, APIs, philosophy, some of the unexpected hard parts. Things that were tricky about building an application like this. We'll talk about mock data and testing and how those fit together and some statistics of what we built, and then a little bit of preview for what's coming up next around AI. So at a very high level, what is it? It's a social network application, and I kind of contrast that from social media. So a lot of the social media apps that we have now started out as social networks. Like Twitter started out as a social network, Facebook started out as a social network. These are applications that were sort of meant to bring groups of people together that are pretty much people that already knew or interacted or had something in common to bring them together and connect them. And it's evolved over time, largely due to the advertising model, into something totally different, which is basically a semi-personalized mass media where the goal is to just crank out tons of useless content and keep people clicking on it for hours and hours and hours. So this is a little bit of a throwback to what social media used to be and what it can do. I think there's a lot of power to bring people together, to build genuine human connection, to make teams work better together. My original idea for this was really around, the kinds of teams that I've worked on and how they might be able to be better connected and supported by a really good social network, different than the tools that they have now. The experience is really centered around teams or groups. It's not an open world where you're just part of millions of people. It's you being a member of one or more groups and interacting with people in those groups. And it's really built for and around users. The users are the customers. There's no advertising, no data mining. It's not a situation where the user is the product that we're serving to advertisers. This is something that we're trying to build for users, make an algorithm that works for users. And because of that, we're not trying to keep you in the app as long as possible, which is really what all these other products do. We're trying to give you the best experience in the amount of time you want to spend. So if you want to be able to see what's going on quickly, if you want to spend some more time and interact more deeply, it's sort of up to you. But the goal of the product is not to keep you there as long as possible. So I've been working on this for a little over 6 months, and you might ask, why haven't we shipped anything yet? Why hasn't there been a beta? And that's a fair question. And I kind of contrast the idea of an MVP or minimum viable product with this concept from a really great blog called Simple, Lovable, and Complete. And really with MVPs, I think there are cases where it can work. There are a lot of sort of the tech bro approach to startups where they want to just get something out there as fast as humanly possible and just see if it sticks. They have no idea if it's a good idea. They want customers to tell them if it's a good idea. And I think there are limited cases where that can sort of work. I think a lot of these like thin AI wrapper companies where their total market window is probably 3 months, get your product out there in 24 hours or 48 hours and iterate. But I think when you have a product that's entering a market where people have expectations, people know what social networks are, they know what features they have, I feel like the bar is a little bit higher. And I really want to build products that people love and that are valuable. And so I think even the first version of that product doesn't have to have every feature in the world, but it has to be complete. And I think that's a big part of what I've been focusing on, trying to make it as simple as possible, but no simpler, make it complete. And lovable is the hard part, but really I think if the product does its job and delivers value, it has a good user experience that, that's the best you can do. But I really want people to have a genuine desire to use the product. And even for a beta, to be able to collect data and to be able to build some of the AI tools, people actually have to use the product. So they have to see some value in it. And I think some of the examples of simple, lovable, complete that I like are things like WhatsApp, Snapchat, Twitter, Slack, Southwest Airlines. These are products that were extremely simple. It wasn't that they were incomplete. They weren't MVPs. Southwest Airlines' first product was one flight that flew back and forth between Dallas and Houston every day. That was it. It was $20. You could buy a bus ticket for about $10. It took about 4 times as long to get there. But it was a simple product that people loved, and it was complete. It did its job. So they didn't try to open every route at the same time. They didn't have a lot of frills. And I think a lot of these tech products that have been successful have started the same way, very focused, but good products that people liked, that did what they were supposed to do. So that's kind of what I tried to build here. And I think especially because it's a social network, you're not just trying to let people publish content and then let people see the content. You're trying to bring people together through the content. which means things like being able to mention people in content and having people be able to be notified when they're mentioned, or follow other people or hashtags, or get notified when people respond to their content. I think these are all things that sort of bring people together, which is the point of this app. And so you need a certain baseline set of features to make the app work. So that's my rationalization for that. All right, so let's go do a quick demo. Let's see if this works. Okay, so you should be able to see a couple of applications on the screen. So these are the iOS and Android mobile apps. iOS on the left, Android on the right. Pretty traditional social media application, as you can see. So I can scroll through here and see lots of content. One of the things about the app is a little pet peeve of mine. Anytime you see a picture or a video anywhere in the app, if you click on it, you get a full focus screen that you can pinch and zoom and explore that piece of content. So for a sample social media post like this, obviously we support pictures and video. I think there's a video example a little further down. So you've got video down here. You can like. You can see comments. Let's click into some comments. This has got a little bit of a cold start problem because of the way the backend works right now, but it'll be faster than that. So I can see I have a whole series of comments. I can like those comments. I can reply to comments. I can go see who's liked a comment. So you can sort of do all the things that you'd expect you'd be able to do. I can look at likes on the post. If I click anywhere in the app, usually you're going to get one of these bottom menus. So this makes things a little bit more discoverable and a little bit more accessible for people that maybe have trouble finding and clicking on some of these smaller links that are built into it. We have app mentions. So anytime you see a person, you can click on that, go see details about the person. I can message them from here. I can see their posts, a little bit of information. I can follow them if I want. So that's sort of the basics of the social media feed. Nothing that is probably too surprising. I can filter. I can see only my posts. Posts from people I follow, posts with hashtags I follow, and posts where I was mentioned. So it makes it pretty easy to kind of navigate, especially if you're coming in to sort of check new relevant content to you. If I click here, I can see this is me, my picture, my name, my title. I can see the organization that I'm in right now. I can switch this, so I can see which groups I have, and I can go to this other group that I'm a member of. One of the things you'll notice is my profile picture and my name and title all sort of change. So you can represent yourself slightly differently in different groups if you want to do that. And if you go here, you can see that my timeline is different in the different group. So let's switch back to my company group. So let's go through a few things. So notifications are a big part of the application. So I can see all the notifications I've had. You can see these are grouped together. So I can see that somebody I follow made a post. I can see that 2 people reacted to a post. A couple of people reacted to a different post. So we kind of group these things together. So if 50 people like a post, you don't see 50 messages in here. You see like one message with a 50 next to it that'll take you to all the people that like that post. And I can mark them all as seen. I can drill in. It'll take me to that content. Okay, so let's go from here. Let's look at, we can go to Discover. That'll show us all the people in this group and all the hashtags. It'll allow us to quickly search. So if I want to go through here, I can search and find somebody pretty quickly by name or title. If I click on anybody in here, like you saw before, I can follow this person. I can see their posts, message them. The timeline that we've already talked about, and then we have a messaging function. So here I have a set of messages. Let's go over here to the other application. So here I'm logged in as a different user. I'm going to go into my messages over here so you can see we have some messages, some in common. So if I go in here to my message with Brandon, my DM, and if I start typing, you'll notice on the other window that you'll see a typing message. You can see that I'm typing in here. And if I send a message, it'll pop up there. But let's just go into this one. So if I say hello, you can see that I'm typing. And I'll hit enter. And the message shows up for both of us. And then you can say hi. So we have messaging. You can go into different channels. You can see the members of the channels. They're admins of the channels. I'm not an admin of this channel, so I can't really do a ton of stuff. I can't kick other people out or make other people admins. I can add new members. I can leave the channel. Let's go to a channel where I am the admin. This channel. So I click in here. So as an admin, I can go change the channel details. I can upload an image for it, set its name. And I can also do things like I can make somebody else an admin, or I can take them out of the channel if I want to. So basic functionality you expect in a chat app, including real-time status updates and typing updates, typing indications. So let's go to profile. So for my profile, I can see my profile. I can set it to be different for each group that I'm in if I want to. I can see my activity. So these are all the things that I've done in the system. If I click on those, it'll take me to it. I can see my posts from here. I can see the people I follow and the hashtags that I follow, and edit this. Let's go to settings, which is the only other part of this. This is my favorite setting to click because it does something fun. It goes to dark mode. And if I go to dark mode, you can see now we're all back in dark mode. Probably should just leave it in dark mode, but I don't know. For whatever reason, I'm used to light mode. So I have a setting for whether I want to autoplay videos or whether I want to mute videos by default. I can obviously turn that on and off for individual videos. And then for notifications, we have the ability to enable push notifications generally, or for individual types of notifications, you can indicate whether you want to get a push or an in-app notification. So there might be things you want to be notified about on your phone to have it give you a push notification. There might be things that you just don't care about at all. You don't even want to see in the app that that's something that happened. You can turn that off altogether. So you have a lot of control over the different kinds of things that might give you notifications. And they're also device specific. So if you have your phone, you might have different notification settings for what you want to be alerted about than on your laptop, for example. So that's the gist of it at a very high level. I think I kind of covered the bulk of what the app does. It's pretty functional social network. It's got posts with comments and replies and reactions and messages with reactions, with app mentions and multimedia content wherever you want to have it. So that is the gist of that. With that, I'm going to shut these down. And let's see if I can navigate back to the presentation. Excellent. Okay, so the tooling for this, the mobile applications for iOS and Android are written in Flutter, which is a Google product, tech stack. The language is Dart, which is a strongly typed language. I've used a lot of these kind of multi-platform mobile application development environments before. This is by far my favorite. I've actually written one before. I've written native applications before. I feel like this is a good choice. The quality of the apps is very good, especially with a media-centric app where there's not as much Chrome from the underlying OS. I think these apps look great. They perform well, and you have one code base that runs on multiple clients. So that's pretty nice. The server side, the web server side, it's Next.js with TypeScript. I'm not sure I would do TypeScript again if I had to do over, to tell you the truth. It's fine. I think I fight with it as much as it helps me. Next.js is essentially Node.js plus React. I think for the website and the web client app, it's pretty useful. For the API server, which is where most of the code is, it doesn't make a whole lot of difference because that's all pretty vanilla, lightweight Node.js kind of code that doesn't really take advantage of React. So I think the API server probably could have just been done in a vanilla Node. It would have been fine. But Next.js has been working for everything else. On the back end, we use Google Cloud Firestore, which is not Firebase, but it's a document database that sits behind Firebase, and Cloud Storage, which is just the general bucket of objects kind of storage like S3 on Amazon. The day-to-day dev environment for me is Visual Studio Code with GitHub Copilot. I find myself using Copilot for really, it's helpful, but it's a lot of rote implementation. It's a lot of things that I would have a junior intermediate engineer do. It's pretty bad at solving hard problems. It's pretty bad at architecture. It's pretty good at things like, hey, I need to go filter this list on this criteria and output another list where this object is slightly mutated, whatever, like things like that. So I use it for that. It's definitely helpful, but it's maybe a 20% time saver, but it's not really radically shifting what I'm able to do, I don't think. And then we use GitHub for source control and for CI/CD. So the architecture, the priorities, I want something that's going to scale. I know people sometimes are critical of building things for scale too early because you're spending time and energy on something that may never happen. But I think if you know how to do it, it's not that much harder. So I want to build something that's going to scale to many millions of users, something that's highly available, inexpensive to run and to operate, Only managed services. So only things that are highly available, hyper scalable, global scale. They're fully automatic. So I want fully automated, what I'm calling zero ops. I don't know if I made up that term, but no batch jobs, no cron jobs, no queues, no pub sub, no complex orchestration, no scaling that I have to mess with, nothing I have to monitor, no place to spin. Just something that always works and never pages me. So this image over here with everything's fine, that's basically the ops job at every company I know of that runs a SaaS product. And you can say, fine, if you punt on this stuff, it's easy to, you could get away with it for a while, we'll be fine. One of the challenges, and you can always fix it later, right? I think that's what people say. Hey, if this product takes off and it's successful, you're going to have lots of people throwing money at you and you can just spend some of that money solving some of these problems. And that's true. But I'll tell you, having seen this up close, what happens is when you grow and it's time to solve that problem, you're going to have a couple of your best engineers spending a lot of their time and energy working on this stuff. Instead of building cool features and things that can push the product forward and help you innovate, they're going to be working on this crap. So I think it's easier just to get this right to start with. And I don't think I'm going to regret having done that. So here's the basic architecture. It's pretty simple. It's the Flutter clients. This could really be any API client. The APIs are really the application, and any client could connect to them in the same way the Flutter clients do. But the clients connect to the APIs. They authenticate to Auth0. I chose Auth0. I was a CTO of OneLogin. I've been in the IDaaS and Auth space for a long time at a pretty high level. I know who these companies are and how they operate. And the fact that I chose Auth0 is probably just says something just by itself, but extremely scalable, well supported, just a lot of good reasons, a lot of expert help. This is their business. They care about whether this works or not. They're people that will help you make it work if it doesn't work. It's just very different than a lot of the other solutions that exist, particularly the solutions that Google offers that I felt were kind of lacking and not well supported. So Auth0 on the authentication side, so the client connects to Auth0 to authenticate and get a token. It then connects to the API server to exchange that for an API token. That API token has the same lifecycle as the Auth0 token. And that allows us to have an API token that we can authenticate with the payload that we need for our session. And we can do it pretty much instantly with no network I/O in a stateless way. So it's a fast, secure way that we can authenticate all these API calls without having to go back to any external service to do that for some period of time. The media is all on Google Cloud Storage, so all the videos and images are on Google Cloud Storage. When a client wants to write a piece of media, it calls the API to get assigned URL that's good for 15 minutes that allows it to write an object to cloud storage. So it's writing by permission only. That gives us some security control, and the read is it's world read, but the objects are all UUID4 named, so they're cryptographically sparse enough that that's considered secure. I have a sort of a longer term solution to that that's a little bit better. Cloud Firestore is underneath that. It's our document database. That's where all the data lives. And then Firebase Cloud Messenger is the product that sends outbound messages to waiting clients. So this is both push notifications and WebSocket style data updates within the app. That's the basic architecture. So the good part of that, Cloud Firestore, as a database, and I hesitate to even call it a database, but as a database, it is extremely high scale. It's extremely fast. Everything it does is instant. It's all index driven. The write scale is crazy good. Like, it's awesome, but it has a lot of constraints, and you will spend a lot of time and energy trying to architect your application around those constraints. But if you can make it operate within those constraints, it checks all the boxes. Google Cloud Storage has been around forever, pretty vanilla. I think that's kind of a solved problem, being able to read and write objects at high scale. And Auth0, super scalable. They support some of the largest customers in the world doing this kind of work, way bigger than I'll ever be. And they do that very well. So these three services, I am fully confident, are going to be hands-off, always working, and a solid basis for the overall architecture and all the goals I talked about earlier. The less stable stuff, the things I'm a little more concerned about, Firebase Cloud Messaging, it's a free product from Google. It doesn't really have an SLA. For push notifications, it's great. Like, that's the only way to send push notifications to Android. And when you send push notifications to Apple, it just routes them to APNS, which is the Apple push notification service. And if for whatever reason that didn't work, you can just call APNS directly. It's not a big deal. So I think that part of it I'm fine with. I've had good experience with the data messages, with the WebSocket style communication for things like the typing notification that I showed and all the different kinds of status updates. It seems to work fine, but I've seen complaints online of people that maybe Maybe their use case isn't exactly the same as mine. So anyway, I'm just a little bit not 100% sure this is going to be the final solution, although it has seemed to work so far. But there are a lot of well-supported commercial alternatives if this, for whatever reason, doesn't end up working. So that's kind of in the maybe category. And then I think the weakest point of this is my Next.js instance running on Vercel. Vercel is awesome. I mean, you can stand up a Next.js website with an SSL cert and CI/CD from your GitHub repo with push to deploy in like 5 minutes with no exaggeration. It's crazy how easy it is to get it set up, and it works awesome. And it's the fastest deploy I've ever seen of a node type product in a production environment. It's like 60 seconds, maybe 90 seconds to full deploy. The environment management, log management, it's all really slick. I'll tab over there and just kind of show you. So this is sort of what the main page for the project looks like. I can see the last time I deployed, what change list that was, when it was. I can go through and look at logs. Probably won't have any recent ones. So I can do from the demo, yeah. So I've got logs there. I can go to settings. I can see like my environment variable management, and they just do a lot of really clever stuff. Like when you go to add an environment variable in this key field, if you just paste an entire environment file into that text field, it parses it all out and just jams it all in there. It's pretty cool. I mean, this is a very slick environment, and the server has worked great. I have really no complaints. My sort of concern is around, what would happen if I had to scale this thing up significantly. So I did kind of build it with that in mind, that all the API endpoints use the Next.js edge router. So those are ephemeral, stateless cloud functions like any other kind of cloud function, and they use a subset of Node.js, so they're very portable to other environments. I thought I might end up putting that on Google Cloud Functions. And after looking at that, I was not convinced that was a great solution for this. I have a lot of API endpoints, and they have they use semantic paths, so they have values in the past that have to be passed in. I don't know. There's some reasons why, and from manageability standpoint, I don't think Google Cloud Functions is the way to go. But Google Cloud Run, which is essentially their mechanism for running sort of highly automatically auto-scaled containers, that it is portable to that. And one of the big benefits of Google Cloud Run is that Next.js, Vercel, is a standalone company, and they don't really advertise it, but their data centers are deployed inside of AWS, and all the rest of my data center stuff is in Google. So even though they're both in a similar region, I've still got about a 50 to 100 millisecond penalty every time I go between the two. And it'd be a lot nicer to have everything in one data center, so my API server and all the backends together. So at some point that will happen, and that will look a little bit like this. So the clients will talk to a global external application load balancer, ALB. That's where you'll terminate your SSL. So you'll have your certificate there. That has the benefit of Cloud Armor is attached to that. So you can literally, with the checkbox, turn that on. So if you want a WAF, you want DDoS protection, the kind of things you'll need at scale, super easy to do. No configuration to the ALB required to turn that on and off. It also has Cloud CDN integrated similarly, sort of checkbox automated, easy to extend that as part of the ALB. That would route to an API gateway. That's sort of optional step at this point. The API gateway, typically people would terminate authentication there. I do that at the API implementation itself, and there's some reasons why I kind of like it there. But if you did terminate it at the gateway, that allows you to do things like rate limiting on a per customer account basis, which we'll probably have to do at some point. So the API gateway would be for things like that. Then you have the API underneath that running in Google Cloud Run. And doing all the cool auto scaling, and then still talking to Cloud Firestore. Everything else still sort of works the same. The one difference would be that instead of the clients reading media from the cloud storage directly, in this sort of model, they would read from a URL that would be at the same endpoint as the ALB, your API endpoint, and then those would get mapped internally by the load balancer to the Cloud CDN, and all those files would be served from the CDN, which means they're going to be much faster. Response for customers to get those files globally, and you're going to have very few reads against the cloud storage. So this is sort of the correct solution, and this solution has everything running inside the same data center at Amazon or at Google, which is a big advantage. So I wrote this slide, and then a couple of days ago, and then I sort of felt guilty that I hadn't done this yet. So I actually just went ahead and did this. I was thinking it would take me like a week to get this all working, and it took about 4 hours. It was a lot easier than I thought it was going to be. And the main steps for this were You go to GCP and reserve an IP address. It's the biggest trick with all this stuff is just there are 1,000 products in GCP. So just to find the place where you reserve an IP address, like you literally just have to use the search bar because there's so many menus of different groups of services. But anyway, you reserve an IP address. You go point your DNS to that IP address, and my DNS is through a different service. So I point my DNS to that IP address for this new API endpoint. And then to deploy to Cloud Run, all you do, assuming you have a project set up and you have the G Cloud tools already installed, which you probably would do, you literally just go into the directory of your Next.js app and type Google Cloud Run deploy, and that's it. You don't have to define the container or anything. You just literally type that command in. It figures out, it uploads the source, figures out how to build the appropriate kind of container, and deploys it. And it's pretty awesome. I mean, it works pretty well. Cloud Run itself is pretty awesome. I mean, the demonstrations I've seen of how the auto scaling works and how fast it's able to scale up and down, just the fidelity of the whole service and how manageable it is. Like I'm apprehensive about auto scaling being fully automatic, but I'm pretty comfortable with this. It's very, very slick. But anyway, you do this, and then it'll deploy it and it'll give you back a URL, a big, hairy, ugly, long URL on port 3000 somewhere inside of Google, and you can test that your application is deployed properly. That'll take maybe 10 minutes. And then you go into GCP to create your ALB. They have a really nice wizard where you just kind of hit next about 5 times, and then you get to the configuration section, and you hit all the defaults. You use the IP address that you'll have named this IP address. You'll use that by name here. You'll choose to have Google Managed Certificate. So you just literally check a couple boxes saying, hey, I want to have Google Managed Certificate to this IP address, and here's the domain. If your DNS hasn't fully percolated back, if it's not fully live to Google, this may take a while. And what it'll do is it'll actually deploy this whole thing, but you'll have a certificate that is not signed correctly, and you'll get certificate errors if you try to test to the HTTPS endpoint. So you just have to sort of wait for this to be ready, and it'll show you in the status, like if it's pending or ready or whatever. And then you point the ALB backend to the Cloud Run endpoint. So you create this network endpoint gateway, I think it's called, but it's pretty point and click. So as long as the Cloud Run is set up, you'll just be able to pick from a list of where you want to point the backend to, and that's literally it. It kind of worked. I mean, I spent a bunch of time messing around with environment variables and some other stuff after that, but this was more or less a working system. I'll kind of show you, like in the Google Cloud admin, what that looks like. So I pinned so you go to VPC networks IP addresses, and this is where you make your IP, where you go reserve your external IP address. This is the Cloud Run setup. So this will actually configure itself when you run that command. It'll do all this for you. But you've got a running Cloud Run of your container. I can see the logs, pretty comparable, maybe slightly better than the for sale version of that. I can go and look at revisions. This is actually pretty slick. I can balance load between different revisions. I can canary test. I can do that through this user interface. You can also do this by uploading YAML files. So if I deploy a new version, I could deploy a version with no traffic. I could send a small amount of traffic to it. I can move the rest of the traffic or move it back. I can do all that with like YAML on the command line if I want to, or I can do it through here, which is pretty nice. It's pretty cool. And I can revert super easy. I can literally just click this and revert to a previous version. So that all works super slick. And then the other part of this, and which you never really have to touch after you've set it up, but once you've set up your application load balancer, which looks like this, I guess I'm really going to go up into here. But once this is set up, this is sort of global scale, magically works. The auto scaling happens at the Cloud Run level, not here, not in the gateway. So this is pretty much fire and forget. Like once you have this set up, you don't really need to go back and touch it. So anyway, I haven't moved the clients over to use that backend, but that API backend is up and running, and that's going to be the production backend like tomorrow. So let's talk about API. So because of the kind of application this is, and the goal is really to let people have access to their data and use it however they want to, my intention is to have the full functionality of the app provided through public APIs that you can use however you want. These APIs you authenticate to as your user account, as the end user. You'll have the same limitations, same security limitations, same rate limits as if you were using an interactive application. But you can call those APIs and do whatever you want with them. So if people want to write third-party clients, if you want to write an integration that grabs data out or injects data in to your social network feeds on behalf of you can do that. Just a side note, because I tend to tell people that are technical, All of this API documentation that I'm going to show you is in OpenAPI, which used to be called Swagger. And there's two ways people do this. One is they use this JS doc style where they put the documentation for each API in the implementation of the API. So in the actual file where the API is defined and implemented, you put the documentation for that particular API. The other way to do it is sort of this mono doc, which is what I ended up doing. So I have a 3,000 line OpenAPI.yaml file that has documentation for everything in it. And the reason I chose that, and it's kind of a bear to work with, first of all, there's some good tools to work with those documents that allow you to navigate them pretty easily and find the things that you need pretty easily. Secondly, I think it's a lot easier to do big refactors. So if I need to go do a big search and replace or move a path around or find all the places where I use a variable in a certain way, to know it's all in that one document and I'm not mixing the code with the documentation of the code, it makes it a lot easier to find and global search and replace the things that I need. And I just find it easier to work with that YAML data than I found it to work with commented blocks of YAML inside of the implementation file. So anyway, that's kind of a digression. So let's do a quick API demo. So this is the API endpoint, and at the top level of the API endpoint is the documentation. So this is api.TeamSpark.ai. You can see I'm logged in as my current user. I can log in and log out here. And then I've got my sort of traditional Swagger documentation down here. So the way that you actually use it is, the first thing you have to do is you have to authenticate and get an API token. So we have an API endpoint that does that. You can paste the token in here if you have a token. If you don't paste the token in, it's just going to use the token from my current session. So the fact that I logged in here means I have a Auth0 session with TeamSpark, and now I'm going to use that to generate an API token. So all I have to do is hit execute here, and I can put a device ID in if I want. I'm not going to do that right now. And then I get back a big old token. So this token is signed by a key that we maintain on the server, and it has a bunch of session state in it that we're going to use. So I go to authorize, I'm going to paste that in there, and authorize, close. So now any API that I call that has a little lock next to it, which is every other API in this in the set, will automatically get that bearer token that has that API token in it. So now I can go call some of these APIs. So before I do that, I'll just give you a rough overview. So we have a bunch of sort of session action notification APIs. I'll talk about what those are in a second, and the upload API. I have some AI APIs. Some of these will probably end up going away. Summary and question will probably stay. Like this is the ability to get a summary, an AI generated summary of your social media feed or messaging channels, and you can sort of filter and tweak that in different ways. And this is the way that you can just do a traditional ChatGPT style question and answer, prompt about your social media activity that has access to that underlying activity. And media summary and embeddings are kind of things we use internally right now, so this probably won't end up being in the public API. So we have a bunch of things around the profile, which is kind of the user of this thing. We have people and hashtags and the ability to find them and follow them. And then we have a big posts API for all the things in the social media feed. And then we have messages, which is all the messaging functions of the app. So let's give an example of this again. Okay, so that time it worked. Pretty quick, 200 milliseconds. Like I said, that's definitely took some time off by moving everything to the same data center. One of the things there is that if an API is calling into the backend database and doing one query and returning those responses, you basically save 100 milliseconds. If there's an API that's doing multiple backend calls, you're saving that on every one of those backend calls. So if you go get a bunch of posts and then you have to go hydrate that and get some other information to fill that out, or maybe you make a couple more backend calls, having everything in the same data center basically makes those free, which is nice. So that'll hopefully impact the system design in a positive way. So you can see I got this. Every API returns with some metadata, so they all have the API version. They have the elapsed time of the call, and then whatever information specific to that API endpoint, and then the actual payload of the API. So in this case, I got a list of posts, and you can kind of see what that looks like. So you can do that with every API endpoint. Anything you can do in the app, you can do from this page through these APIs and through apps that you write against these APIs. So that's sort of the gist of it. So let's talk about some of the unexpected hard parts. One of them is maintaining notifications and notification state, especially around the feeds. So this is something that it's pretty easy to get an app stood up where you can have a list of posts and show the user the posts. Like that was quick. But then when you start thinking about how people really interact with that and some of the requirements around that gets a little trickier. So understanding what things happen that people might care about and how to keep track of those things and whether you've told the person about it or not and whether they've seen it, that turns out to be really the harder part of this problem. The other big hard part is synchronizing messaging state. So for the messaging application, this idea that you have kind of a real-time bi-directional communication that happens, that you need to notify people of changes to channels. So when new messages show up, when the typing state changes, you need to be able to show somebody the red state of everybody else in the channel to see which messages they've seen in semi-real time. That ends up being a much harder problem than at least I expected it to be. So again, it was sort of like basic, make a channel, put stuff in the channel, see the stuff in the channel. That was super easy. This was the hard part that took more of the time. So the way I solved that was with a thing I call the action audit log. So this is really an audit log on steroids. It's not unlike an audit log you'd have in any kind of SaaS product, but it has a lot more context in it. So again, I have some basic metadata around it. I have the type of the action that was taken. So it might be a post or a post mention or a comment or a reaction. The action itself, which is sort of your CRUD part of it. The primary record ID and secondary record ID, which depends on the type of the action to kind of get you into what the thing was that the action was taken on. The context of the action. So for example, for a reaction, it would be the actual reaction itself would be in the context. And then the person who did it, which is the action person, and the target persons are anybody who might need to be notified about it. So for example, if it was a post mention, the action person would be the person who made the post, and the target persons would be the people who were mentioned in the post. And then we keep track of which of the target people have seen this particular action as a notification in the same record. So we have this one big record that sort of handles all of that. And then we do action record processing. So every time some event happens in the product, it creates a set of action records, maybe more than one. So if you do a post and the post has some mentions, some hashtags, and some other things, there may be several action records that each have different target users that might care about those actions, all related to one physical thing, like a new post happening. So those action records get bundled up and sent into a central processor, and that processor determines what to do with those actions. So basically, who needs to know about these? So is this something that might be a notification that somebody needs a push notification for? Is it something that it's a real-time data notification that they care about? It'll basically filter all that stuff out, group them together, and send them in a minimum number of messages to the devices that are targeted through Firebase Cloud Messenger. The originating device never gets these messages. They never come back to the originating device. So the model is, if you're the originating device, you need to keep track of your own state for things that you generate. And as I said, these can be push notifications or they can be internal data messages. So for the notification system, as I said, so the action record processor does the push notification part of it. So it tells people when things they've configured per device are things they want to know about. But the other thing it does is it's a set of stored records that keeps track of the state of whether they've been seen by each of the target users that shows you your notifications that are aggregated together. So you saw, I think, a little bit in the demo when I showed the notifications that if you have let's say you have a post and 50 people like that post, that might be a bunch of different action records, but it's going to show up as one notification of there was a post that was reacted to, and here are the 50 people that reacted to it. So there's some aggregation that happens there. And we also keep track of which of those things the person has seen or not. And we have the ability to mark whether you've seen something either explicitly, like when you hit the mark everything as read, or when you navigate to it from the notifications page, or in some other circumstances when we know that you visited a specific piece of content, then we'll mark that as seen. So there's a whole thing that kind of permeates the whole API internally about keeping track of which actions people have seen, so that we can keep all that state managed. And then client synchronization for cloud messaging was the other part of it. So this notion of like being able to send all of these messages about, hey, this person is typing, this person just posted a message, this person's just read some more messages in the channel. All of that's happened through this same central processing of action records. And again, those can also send push notifications, or they can just send data updates for this sort of WebSocket type communication that happens. For most of what we do for the messaging, it's just data messages, and the data messages use this WebSockets type approach internally. So it's bidirectional. The clients listen for the messages to come in, and then they react to it. And it doesn't require APNS for the data messages. That's implemented separately by the Cloud Messenger. Okay, so let's talk about mock data and why we need it and what we do with it. So why is it important? I think mock data is important for a bunch of reasons. System design being the first one. I actually started building the system by constructing a JSON file with the data in it of what I thought a social network looked like, and then writing some simple web code to render that on the screen so I could sort of see if that looked right. And that, I think, introduced a bunch of areas of improvement. And the app kind of evolved very quickly around the data. Before there was any code, there was data. I think in more scaled environments, being able to set up tenants for salespeople, for customers, lots of different use cases. Every company I've worked at's had a challenge around this. How do we set up a demo environment that's fully populated with data for customers to go use? Interactive testing for developers is another big use case. You want new developers to be able to come in, quickly get productive, and be able to have data they can test against, real production-like data without having to create it themselves. And without having to test it against your prod or your staging accounts, but to be able to set up their own tenants that they can go play with. And then lastly is automated testing. You need to be able to run automated testing against realistic data, and to be able to populate a tenant with sort of non-trivial realistic data is important. One side note, which I guess probably shouldn't need to be said, but I've seen this happen enough that I'll just say it anyway. You never, ever should use redacted real customer data or a process that continually redacts customer data to build your mock data or your test data. I've just seen it go sideways. I've seen the people who maintain those scripts go work somewhere else, and then a database changes, and then all of a sudden PII is now outside of production. Like, just never, ever use real data, even if you redact it. Just start from scratch. So we have a complete social network represented in one big JSON file. So it's people, posts, comments, reactions, channels, messages. Everything that you see in those demos is in one big JSON file. And then we have obviously a directory of the supporting media files behind that. And what we use that for, so we have a populate function in code that can create a tenant. You can pass it in a JSON file. It defaults to the main one that we use, but you can pass whatever JSON file you want that is the right format. You can give it a tenant name if you want. The convention is it'll do test with a GUID after it. But if you're using it for a developer account or a demo account or something you want to stay around for a while, you should use the ID of the person as the root, and it will give you back a tenant that has that ID and then some random characters after it. But you want to be able to keep track of where these accounts came from and who owns them. We have date offset logic. So all of the events in the mock data happen within a defined window of a few days. And for testing, typically you don't touch that. You just leave it where it is because you want to be able to confirm that the dates are all what we think they ought to be. But for creating a demo tenant, you want to update those dates to be recent. So you want the demo data to appear to be within the last week old. So part of the date offset logic basically says take today's date and pull every event forward far enough that it doesn't go past today, but it's basically recent. So when you see a demo that's from this mock data that everything has dates of February 2024, it's all going to look like it was from last week. That's a pretty important piece to this whole thing. And then account overrides. So the populate function can basically replace any account in the system with a specified account. And the reason that we need to do that is because you want to be able to log into that tenant as yourself. And you might want to be able to log into that tenant as more than one actual user ID that are not the sort of the fake IDs that are in the mock data. So we have these account overrides. So both of those demo tenants, for example, that I was using, were using like real world accounts that I overrode in the mock data when I built them. So that's kind of the fundamentals, I think, of what you want. You want to have this set of mock data, and you want to have a function that can build tenants in this way. Then we have a couple scripts that you can run. One of them called tenant upload, which creates or updates a tenant, and a tenant delete, which cleans one up. And you can pass any of those parameters you want when you use those. So let's talk about testing a little bit. I really like avoiding mocks. I hate the idea of testing against someone's interpretation of how something was supposed to work. Sometimes you have to do it. There's one case in the entirety of all this code base where I had to do a mock to test something. But generally speaking, I want to test in production against the real backend systems with realistic data on the actual infrastructure as much as possible, because I want to verify that not only does my code work, but the code when deployed to production will work. So our goal is to automatically provision and stand up a tenant in production, populate it with high fidelity data, run API tests against it, capture the results and coverage. And if those tests pass, the system is good, period, full stop, end of sentence. That's the system. You should be fully confident that if you do a big refactor and the test passed, you can check it in and deploy to production. Anytime the test passed, you can deploy to production. There's no further testing required. So we have to keep a very, very complete set of tests. And let me see if I can just give you a quick idea what those look like. So here's the mock data, first of all. Just what you'd expect, lots and lots of JSON, 1,000+ lines of JSON. Let's see, I gotta grab the right, there we go. okay, I don't know what I did wrong here, but you get the idea that we have a whole bunch of tests, and we can. It's not exciting if they've all succeeded because they all just have a little check mark next to them, but you can see the time next to them, and then you can see the coverage. So coverage is pretty decent. I've basically reviewed all the places where the coverage is not perfect, and I'm comfortable with it all. So we have about 250 plus API tests. They cover 88% of the code under test, and they run in about 4 minutes. If these are running locally, they'd run super fast, but they're running against real production services. So they're actually going and reading and writing to the underlying production data services. So 4 minutes is kind of a long time if you're doing these a lot, especially if you're actively working the APIs, but I think it's worth it. They break more often than you'd think, so it's good that they're there. The test code is about 42.5% of the total code base, which may seem like a lot, but I would say these metrics match up with some of the best code bases I've worked on. I think this is sort of the goal that you shoot for, which is coverage around 90%. A little less than half of the total code is probably going to be test code. And I already sort of showed the test output and the coverage. So some statistics, about 15,000 lines of Dart code in the mobile apps, a little over 17,000 lines of TypeScript in the web server. Almost all of that's in the APIs. Implementation, very small amount, and the rest of it. So a little over 30,000 lines of code. It's not the most productive I've ever been. That's 6 months of 60 plus hours a week, every week, actually writing code. I think the most productive I ever was on a line of code basis was probably twice that much, maybe 3 times. But it's fine. I think there's been a lot of refactoring, a lot of design as we go. And it's still, it's a decent sized code base. There's 65 API endpoints, about 250 unit tests of those endpoints, and 88% of the coverage of the code under test. So let's talk a little bit about the coming soon. We talked about TeamSpark, but we didn't really talk about the AI part. I really don't want to be on the AI bandwagon. I think there's just so much crap out there, but I do feel like there's an opportunity to apply large language models to social media in a responsible way that is going to make the experience better for people. So at a very high level, there's a bunch of features, but at a very high level, I think the notion of summarizing, so being able to say, hey, what did I miss in my timeline, or what did I miss in messaging, without having to go back and look at everything, to be able to get a quick overview, and to be able to even have that overview include clickable links so you can go in and see the things. I've had some good experience. We're still working on some prompt engineering, but I've had pretty good experience with producing concise summaries that really hit the high points of the things that you care about as a user. So that's one of the features. And then the other part is interactive AI chat exploration of the social feed and messaging history. So you can sort of, ask it questions like you would ask any GPT, but it'll have the context of what's in your social media feed from the app and your messaging. So I'll talk about some of the design and implementation in the next episode. We do vector indexing, generate embeddings for the text. So we don't just give the language model your entire social media feed. We go through and figure out what it needs, and a concise way to grab all that stuff, and to be able to search large amounts of data to be able to pull that together. But I'll go into a little bit of that, like the retrieval strategies and how we use Vertex AI for that. The media file, image and video to text, we use Vertex AI or Gemini with an image model that works pretty well. So to summarize images to text and videos to text, and there's some tweaks to make that work right. They'll talk about how we do our prompt design and augmentation with platform data. So how we sort of combine the vector indexing and embeddings with the search text and the underlying data. We have to build effective prompts to answer some of these questions, and then just sort of wrap up with the total implementation. So anyway, that'll be a whole episode that's probably as long as this one, just going into the nuts and bolts of that coming next. So hopefully you'll join me for that. And that's kind of all I have there. Thanks for watching.